Hello, welcome everybody. Tonight is Michigan CNC online webinars. My name is Ted Gauthier, and tonight we have a guest speaker. His name is Erick Royer. He's director of Stepcraft USA, and Erick has graciously volunteered to give us a little presentation and let us have a little bit more information to find out what it takes to put a tool changer and to automate your CNC. So what I'm going to do is I'm going to go ahead and pass the presentation role over to Erick, and Erick's going to go ahead and give his presentation. I hope you enjoy it. We have a CNC seminar every first Tuesday of every month. So if you'd like to join us, just let us know, and send me a text or an email, and I'd be happy to put you on the list to notify you when we have these CNC seminars. So usually they're the first Tuesday every month, 7 p.m. Eastern Time. Sometimes we do not have them if there's a holiday. We'll change the date or we'll cancel it for that month. But for most purposes, first Tuesday of every month. We also have these recorded. They're on YouTube. You can find them on YouTube by searching Michigan CNC Webinar and Tips. So with that behind us, I'd like to welcome Erick Royer.
All right, hi, yeah, right. Good start, right? I can't even say hello. How's everybody doing tonight? Thank you for having me on, Ted. I appreciate it. So I've got a presentation that I put together here to talk about automating your CNC machine with a tool changer. Now, just to preface this, yes, I'm the director here at Stepcraft, and I am going to show you pictures of tool changers that we make, and they're going to be on our CNC, but that doesn't mean that they can't be in some way, shape, or form integrated with other CNC machines. So we'll talk about that at the very end. But I thought that I would go through and tell you, first of all, who I am. So I'm the director of Stepcraft here. I'm located in Torrington, Connecticut. I've been in the CNC industry, using the CNC, I guess, as a user between that and 3D printing for over 10 years on many different types of machinery. My whole life I spent playing with toys. I was from I don't know, about 22 years old on, I was involved with the radio control hobby industry. So me and a couple other people started a website called rcuniverse.com, which is still in existence today. We've sold it about 8-9 years ago. It turned into one of the largest forum websites in the world for the radio control hobby. So I as part of that, I built a lot of model airplanes, a lot of model boats, helicopters, you name it, I built it. And so that's how I got involved in CNC and 3D printing, because I was using those devices to make parts and, make custom models and things like that. After we sold RC Universe, I went on to work as an executive editor for Maplegate Media Group, which was a publishing company that published 6 different model magazines, whether it be cars, boats, planes, even robots. So I was involved with the Robot magazine, which got me further involved with CNC companies, because we would do reviews on them and 3D printers. And that's kind of how I ended up meeting my partners and really developing Stepcraft here in the U.S. So a little bit about Stepcraft. So Stepcraft was formed in 2012 in Germany by 2 partners, Peter Urban and Marcus Wiedel. Their original focus was on the desktop CNC market for hobbyists and makers. They had 4 size machines, which we still have in our line now, but they started with 4 machines that were roughly 8 by 8 inches to 16 by 24. So they were really, desktop size, and that's what they ran the company with for about 2 years, and that was a version 1 machine. They had just released a version 2 machine, and at that point the company was growing pretty rapidly throughout Europe, and they Marcus had come over from Germany to Chicago and leased an office out there and basically bought everything, furniture, computers, plants even, and decided that he was going to try to find somebody to run the company here in the U.S. And so what he did was he locked the door, and then he flew to Connecticut, and his plan was to give us a machine at the magazine to review. So the day that he came in to our office just happened to be the day that I decided I was going to resign at my job. I didn't want to do it anymore. It was a long drive. I was just ready for something else. And so he did a presentation, and we went to lunch, and it was just him and I, and he was telling me about what he did with the company, and he started in Chicago. And I said, well, okay, no problem. I said, I'll run the company for you, because when I leave lunch, I'm actually going back to give my resignation. So one thing led to another, and, you know, we spent a few hours kind of figuring out how we would do things, and that's basically how it started. He left for Germany. I went back and left my job and literally started Stepcraft about a week later. We ran it out of my basement. I rented a RV and a trailer, and we drove to Chicago and brought everything back to Connecticut, and that's pretty much how I started it. Selling out of my condo and helping people as much as I could to get the name and the brand out there in the U.S. I launched a Kickstarter campaign in March of 15, and that was kind of my idea to let the world, or at least let North and South America, know about Stepcraft. And I was hoping that we would sell, I don't know, 10, 15 machines. I thought that would be great. And the Kickstarter campaign yielded over $500,000 in 30 days. And that's really the boost we needed to launch the company here. And the rest was kind of history. Today, we have over 10,000 customers worldwide between our offices and Germany. We have over 30 dealers serving 50 countries. We don't have any dealers here in the U.S. For North and South America, we pretty much do everything out of Connecticut. I have a tech support person. He's actually my level 1 support, who's in Mexico City. So he helps me with any of our Spanish customers, Spanish-speaking customers, and we take care of everything else, on this in this hemisphere, I guess. Between the two companies, we have over 50 employees between U.S. and Germany. So the company's growing. We're, figure 2012. I'm in my 5th year, almost 6th year here. So it's been quite a ride. This is the Kickstarter campaign that we launched, and what happened was they had a version 1 machine. They were launching a version 2, and part of the version 2 was the machine on the screen right here. It was the 840, which is roughly a 2x3 foot desktop CNC. And there was a lot of new attachments that came out for it, and so it was a really good time to do a Kickstarter campaign because there was a brand new product that was coming out. And we did really, really well. In fact, Hugo, who I just mentioned is my tech in Mexico, was one of my first Kickstarter supporters. So now he's working for us. So that was pretty cool. Right now we're in this is our building on the top left here in Torrington, Connecticut. It's an old ball bearing factory that was built before the turn of I think it was built in like 1890. And they made, I don't know if anybody's ever heard of a Torrington bearing, but it's basically a one-way bearing, and that was actually invented and manufactured here in our building. So we're on the bottom level of the building here. The bottom right picture is our headquarters in Germany. That's the whole building that they own over there. It's a pretty impressive place, 4 stories, and there's a lot going on over there all the time. So we have our initial line of machines was called our D-Series, and D, I guess you could say it stands for Desktop Series. Right now we have letters that denote different models that we have. So the D-Series has 5 different size machines, so our smallest being the 210 to our largest being the 840. This chart is actually on our website if anybody was ever interested to look more about the exact sizes. The D-Series machines, the number denotes the length of the machine in millimeters. So the 840 is 840 millimeters of work area in the y-axis. So it's roughly 33 inches or so. So this is our current D-Series line, and here's a D-Series. We sell packages on our website here because our systems have a lot of different options and attachments. So to make it easier for people, we've created these attachments and these packages. And so this particular package is called our fully automated package, and this is part of what we're going to talk about a little bit later. But this has our 1,000 watt spindle with our tool changer on it and a full aluminum T-slot bed. So this is, again, the 840 size machine, and this is one way that we sell it. So the next line of machines that we came out with, we had a decision to make on what we were going to do with the next step for the company, and we decided that going bigger and getting into the industrial and the production CNC market was going to be our focus. So last year we launched here. I think we started shipping in September of 18. The Q-Series machine. So we have 3 different size Qs: a 2x4, a 4x4, and a 4x8 foot machine. These pictures here, the gentleman on the right is one of our first customers that received the 204. This is at his shop in, I believe he's in New York. And this machine is, he's got a 2.2 kilowatt air-cooled spindle on it. Our steel frame stand, he's got an aluminum T-slot table. He runs this machine a lot. He bought it primarily for prototyping. He's got a couple of products that he's invented, and he's using the machine for that. But he does a lot of rough woodworking too, like the board that's on the machine. This was just a screenshot from a video testimonial that he did for us. The picture on the left, that's Bill Griggs. I'm sure some of you might know him from CNC Router, Router Tips. He has a podcast as well as the Facebook group. And that's me on the right. And he just happened to be in Connecticut. He lives in upstate New York, and he was driving through Connecticut one night. I met him here at the office, I think like 10 or 11 o'clock at night. And we did a quick Facebook Live video. And he had been hearing a lot about the Q machines, and he wanted to see one in person. And that video is actually pretty cool. He was like extremely impressed when I showed him everything that we do here and how the machines are constructed and whatnot. I put these 2 pictures up because it's important to realize the size of the machine. If I didn't have a person in the picture, and Bill and I are not small guys, but if I didn't have us in the picture, the machine looks very similar to our desktop machines, and so they're often confused. But that's the smallest. That's the 2x4. So these machines will do 470 inches a minute. They're very fast. We have a philosophy for manufacturing here called One Tech, and basically what that means is that I have a team of guys in our production facility here and in Germany, and it's one person assigned to one machine from the very first assembly that goes together until the machine leaves the building. And then we have quality control that we perform with other people at the very end. So every machine is badged with that particular assembler's name on it, and it's a way of really bonding the technician with the machine and ensuring that the quality is going to be the absolute best. It's kind of along the lines of Bentley, you know, how they would manufacture their cars, where it's a very detailed, and my guys take a lot of pride when they put these machines together because they're meant to be workhorses. Everything's ball screw driven. We're using I think they're 4 amp NEMA 24 steppers, and we have dual y-axis stepper motors on the y-axis on the 404 and the 408 machines. So the 2 bigger machines have dual Y motors. Everything is constructed from steel and aluminum. Anything orange on the machine is thick aluminum plates that we water jet in our factory. The gantry uprights are actually laminated steel. There's a channel that's built into the center of them. You'll notice on our machine, the only wires you see on any Stepcraft machine is going to be for the Z-axis stepper motor and the motor wire itself. Everything else is hidden in the machine. It's a very clean design. Again, that's that kind of European style. All of the silver parts on the machine are extruded aluminum, so everything is a custom designed extrusion that we have manufactured in Germany. So and if you hold these parts in your hand, they're extremely robust. There's nothing off the shelf with regards to like 80-20 extrusion or anything on any of our machines, even the D-Series. And we're using an all-steel motion system, so our guide system on our machines is a little different. We use an 8 bearing per side for steel roller guide system. So the roller, if you take the ball screws off of our gantry and you slide it by hand, I guarantee it's going to be one of the smoothest gantry operations you'll ever feel. The design it's not cheap. There's a lot of bearings that go into each axis to get everything to move smoothly, but the design is there to ensure that there's as little drag as possible, and the machine it's highly accurate. We spec out every machine when it leaves. It's plus or minus 1/1000th of an inch before it leaves the door. So one of the things that Stepcraft has been known for since the beginning is multifunctionality. We have a lot of attachments that you can add to our original desktop series, the D-Series machine, which can also, many of them can also be used with the Q-Series. So we have our small spindle, we have a laser in the center on the top, we have a 3D printer attachment. That's our 1000-watt spindle on the lower left. We have a 3D touch probe for probing parts, locating edges and centers of holes, and for 3D scanning. And then the bottom right is our drag knife, which we can use for cutting, say, vinyl graphics or different paper, cardstock, things like that. The top left is our hot wire cutter, so you can use that for cutting foam. That was a very popular thing that we used a lot with model airplanes. The two top, the center and the right pictures, those are our spindles with tool changers on them, which I'll get to in detail. We have a wood-burning pen tool. The middle on the bottom is a plotting pen, and the bottom right is a carbide-tipped spring-loaded engraving point for doing like plastic edge signs or engraving aluminum or steel. So the whole gist of this webinar is to talk about tool changers. I just wanted to give you a little bit of background of myself and the company and our products. So our tool changer line, we have 3 automatic tool changers in our product line. So the first one is our HF500 spindle. So it's a 500 watt, which is about 0.7 horsepower. It's fully computer controlled. So the RPM and the on-off is completely controlled by the G-code. 10 to 24,000 RPM. It's an air-cooled spindle. It's designed to run off 110 volts. So in fact, our entire D-Series machine with this spindle, I've run as many as 4 D-Series machine on one 15-amp home outlet. So the machine and the spindle do not draw a lot of power. It's a very efficient system. The tool holders that we use for this particular spindle are small. They're called an SK10, and the collet is actually machined into the actual tool holder. And I have a picture I'll show you in a minute so you can get an idea of the actual size of these things. They have an 1/8-inch collet in them, and right now here in the States I only have 1/8-inch available for this particular tool changer. They have metric sizes available, but we're looking at going up to 1/4 inch. It's something we're working on because when you expand the hole in the center, the walls of the collet get thinner, and we need to ensure that everything stays super rigid. And again, this will make more sense when I show you the picture in a few minutes. The tool changer requires 110 PSI compressed air. You do not need piped in shop air for this. We use little pancake compressors that we get from Harbor Freight for like $49 with a coupon, and they work more than fine. There's not a big CFM requirement. It's just used to activate the drawbar to open up the inside to let the tool out. And you'll see in the center picture off to the left side is a 6mm push to connect, which is what goes from the air valve into there. So this particular spindle is great for hobbyists, for makers. I have jewelers that use them. Basically, anybody that would not need a ton of power. Believe it or not, this spindle with 1/8" tools, it'll cut aluminum all day long. You're not going to take 1/4" passes, but 15 to 20 thousandths passes, it's gonna be fine. It's a very precise spindle. It's just not super big, but it works great. And that's it. That is the spindle with the tool changer on the left. That's on our 210, so that's our smallest CNC with about 8" square work area. And just to give you a scale reference, that's what it looks like. So the next step up, and this is the one we sell most commonly with the D-Series machines, is our MM1000. So this is a 1,000-watt spindle. It's roughly 1.4 horsepower. We do have an interface for it to allow it to be computer controlled on and off. This particular spindle is a lot more like a router, like maybe a DeWalt 611 or something like that, in that it has a manual switch on it and there's a dial on the top that you use to adjust the RPM. However, this isn't a router. This is actually designed to be a spindle. The bearings and the design of it, it's designed to be side-loaded for long periods of time. It was designed to be a CNC spindle. It just has attributes of a router. One nice thing with this is it does exhaust. It's air cooled and it exhausts out the side. You can actually see the vents there right near the red push button. So it's not blowing air down into your work area, which makes a mess. It exhausts everything out sideways. Like I said, there's a manual dial on the top to get you between 10 and 24,000 RPM. To computer control the on and off, we actually have a box that you plug the cord into, and then it goes into the CNC, and it's basically a computer controlled relay that will turn it on and off when the G-code command is given to turn the spindle on. This also runs off 110 volts. The tool holder on this is called an SK15. So it's quite a bit larger. And actually, when we first launched this, to me, it was a huge difference between the SK10 and the SK15, especially because the SK15 uses standard ER11 collets. So it'll handle any size that ER11 comes in, which for our purposes is usually between a 1/16 to a 1/4 inch. I know they go up to 8mm, but I think 1/4 inch is probably the largest common size that you'll be able to use on this. This one also uses 110 psi of compressed air. The neck on this spindle, so you see the aluminum part, you can see where the push to connect is on this. The smaller diameter neck is 43mm. That's the neck of our tool holder on all of our D-Series machines. So that everything we have, all the attachments will fit into a 43mm tool holder circle. That's kind of one of the things that's like our trademark in terms of how things interchange. So this spindle could be used on any machine as long as you made a bracket to hold it that was 43mm, just to handle the neck of it. And again, I'll talk about that in a little bit. So I have a video here that I want to play. I'm hoping this comes out okay. This video will show you the spindle, the MM1000 working on a D-Series machine with the tool changer. It's like 2 minutes long, so I just want to play this because it's more interesting than listening to me talk. Hopefully the video and the audio work out well here. But let me.
In this video, I want to introduce you to the automatic tool changer for the Stepcraft MM1000 milling spindle. Not only is Stepcraft a leading manufacturer in high-quality, high-performance, multi-function CNC systems, but we're the only company at this price range to offer a fully automated tool changer. The automatic tool changer will vastly change the way that you use your Stepcraft CNC system. You can now set up multi-tool jobs and free yourself to do other tasks while the machine is running, while confidently knowing that each tool will be automatically picked up from the tool rack with perfect tool height registration and applied to the pre-programmed tool paths generated by your favorite CAM software. The tool holders for the ATC are very robust, and they use a standard ER11 collet. This allows you to use a wide variety of tool shank sizes for an almost endless selection of end mills and cutting bits. While the functionality of the automatic tool changer works flawlessly, we wanted to ensure that setting up your tools for each job was quick and painless. To accomplish this, we developed custom macros for UCCNC that allow the ATC to work just like the ones found in very expensive industrial CNC machining centers. Simply load your tools into the tool holders and place them in their respective locations on the tool rack. The software will automatically measure the tool height offsets for each tool and store them in the system. Why is this important? Because it means all you have to do is simply tell your CAM software which tool number you'd wish to use, how fast and how deep you wish to cut, and the system does the rest, automatically. If you find that you are spending a lot of time manually changing the tools for your jobs, or if you'd like to get more creative and expand the capabilities of your Stepcraft CNC, then the automatic tool changer is a must-have. For more information on the automatic tool changer or any other Stepcraft products, feel free to give us a call or to visit our website.
All right, so that's a video that we did, I don't know, a few months back for this. That's Dylan. Dylan was in my support department. Now he's in my marketing team. He does all of our videos that you see online. So as you can see, the MM1000 it's a pretty robust tool changer. It does an awful lot of stuff, and it works really efficiently on the machine. And again, at 1.4 horsepower. Now, just in contrast, that's if you're familiar with it, using a DW611 from DeWalt, this spindle is slightly more powerful than that, but it is designed to run. We use both here in the past. And this spindle will outperform that any day of the week, plus the fact that, there's a tool changer, which you can't get for the router. Now, our newest spindle, which we just released officially, I don't know, I guess beginning of this year, is for our Q series. So this spindle is actually, it's the other two spindles were made in Germany. This spindle is made here in the U.S. And I worked closely with the manufacturer of it to design it to our specific specifications. It is a 2.2 kilowatt spindle, which delivers over 3 horsepower. It's completely computer controlled, so the on-off and the RPM is controlled via either a Hitachi or a Siemens VFD. We use Hitachi VFDs here in the States, and Germany uses the Siemens VFD. This spindle, what's neat about this spindle to me, there's a lot of things I really love about this product, and largely because I was intimately involved with, bringing it to market with the manufacturer and getting things the way we needed it for our applications. But the RPM range on this, effective RPM range, is 5,000 to 18,000 RPM. Now, you may ask why 5,000, why do you need to go that low? In fact, I've actually run the spindle down to 2,500, and where I use the lower RPM is for drilling. So a lot of times, if I have, say I'm doing a cribbage board and it's got hundreds of holes in it, instead of using an end mill, which is not the best tool for vertical hole drilling, I'll put an 1/8 inch or whatever size drill I need, and that I'll get a collet to match it, and I'll put it in the machine. And when you're drilling holes, it's to do a hole drill at 18,000 RPM is crazy, and your bits won't last that long. They'll dull out pretty fast, and you develop a lot of unnecessary heat. So this spindle, when you turn the RPM down, like I said, as low as 2,500, it's great for drilling. At 5,000 RPM, it still has a lot of torque, so you can effectively machine at the lower RPMs. I've done some finishing passes on aluminum with it at that range, and it works excellent. 18,000 is where we stop on the high end on our basic spindle, and to be honest, I've never really had any reason to go over that. Some people say with small engraving bits and stuff, you want to get up into the 20s. I've had a lot of successful engravings that I do at 18. I've just never had a need. We do have a 24,000 optional spindle for this that I can get here from the manufacturer relatively quickly. So if somebody absolutely wanted this but wanted 24, we can offer that. This is a passively cooled spindle. So everybody at trade shows, it's funny, everybody's like, what does that mean? So basically what it means is there's no water cooling and there's no air cooling. It's completely sealed. And that usually puzzles a lot of people, especially when we're at a show, because, you know, spindles are supposed to either have water or air. And everybody asks, well, how does this thing stay cool? So the case design on this spindle is designed as such to dissipate heat very quickly. The average operating temperature on this spindle after, say, a 12-hour day of machining continuously, like a long carving, is right around 105 to 110 degrees Fahrenheit. So you could touch this thing all day long and you're never going to get burned. It doesn't overheat. It's just a very cool running spindle. I have to switch here for a second. I'm being told I got to let people into the meeting, and I'm not quite sure how to do that. Sorry, everybody.
That's okay. They should just pop up on your screen.
There they are. Yeah.
Yeah.
I had the screen in the background, so I apologize.
Yeah.
All
okay.
Right.
Great.
Is that good now?
Yep. I think
Okay.
so.
All right. Cool.
There was one fella named. I think his name's, let's see what his name is here. Anyways, if he pops up, you can let him in. Thanks.
Okay, no problem. So again, this spindle's completely sealed, and what that means is it's completely maintenance free. There's no way for dust to get inside of it, so you never have to worry about anything infiltrating the spindle and causing problems with the bearings or anything like that. The other benefit of it is that it is extremely quiet. It is as quiet or quieter than any water-cooled spindle that I've ever seen. A lot of people swear by water-cooled spindles, and I'll tell you the reason that this is an advantage, in my opinion. There's no water pump. There's no water. There's no need for using, worrying about any hoses or anything breaking. I've heard stories where people have had like the Chinese water-cooled spindles, and a pump goes, you don't know it while you're running a job, and the thing starts to overheat. Before you know it, it's spent. So I wanted to offer a product to our customers that didn't require a lot of maintenance and that was going to be easy to use, that was going to be super quiet and very powerful. So this is what we came up with. It is a 220 volt spindle. And again, it's a single phase, so you don't need any special power. It'll work in the average house. Again, the VFD does the conversion from a single phase to three phase for the actual spindle itself. Now, what's unique, one of the other unique things, this spindle, for this size spindle, we use an ISO 30 tool holder. So ISO 30 it's a big tool holder, but it can handle ER32 collets all the way up to 3/4 inch shank. And the spindle is powerful enough to turn, like if you were doing cabinet making, you can turn a 3/4 inch shank, say 2-inch diameter raised panel, if you're doing MDF doors. This spindle will handle those bits with no problem. So it's giving you the ability to utilize tooling that you would normally only be able to use on a 4, 5, 6, 8, 9 kilowatt spindle. You can do it on this spindle without any problems and without worrying about overheating. We did incorporate one other thing into the spindle. On the top, there's 2 air inlets. One of them is for the drawbar that will grab the tool holder and release it. The other one is to allow constant airflow through the spindle and out through the bottom where the cone comes in. And the reason we did that, we don't use it here. We only used it when we do carbon fiber. So whenever we're doing something that has a really, really fine dust, especially a gritty abrasive dust like carbon fiber, then we will actually set it to about 2 CFM of air, and it blows through the case and out the bottom, and it just keeps any of the carbon dust from getting up inside. And so there's an option there if you need it, and which is kind of nice. The drawbar on this thing is ridiculously powerful. It's about 1,000 pounds of force that it's pulling the tool holder up in, so it's a positive engagement no matter what size tool you're doing. The other thing, this also uses 110 psi, just like the other two tool changers. And again, you can use the same cheap pancake compressor. The only thing with this one where you would need a larger compressor is if you did want to pipe in the continuous air going through it. You've got 2.2 CFM or so. A pancake compressor will just run constantly, so you would need something that has a little bit bigger reservoir tank. So this is our biggest tool changer. So I told you before the different tool holder sizes we have. So this is a really good comparison so you can get an idea. The top one is the ISO 30. That's a 1/2 inch Amana O flute bit in there for machining plastic. And the SK15 in the middle, that's the same type of bit. It's an O flute plastic bit, but it's a 1/4 inch shank. And the bottom is the SK10, and that's an 1/8 inch 2 flute upcut bit, I believe. Upcut, yeah. And that's for our HF500. So you can see the difference in tool holder sizes here. When we're talking about the 2.2 kilowatt spindle, we're definitely not messing around. It's a big, robust tool holder. But the SK15 for a 1,000 watt spindle, that is, believe it or not, it's a very, very strong tool holder. And again, with the ER11 collets on there, you have a lot of flexibility for using that on a machine. So if you have a CNC router that's or a CNC machine that's currently using like a DeWalt, the MM1000 with this tool changer with the SK15 is really a good option if you wanted to get into automating your CNC process. So some of the advantages of an automatic tool changer. One thing that we do a lot of is you can load all of your commonly used tools into the machine at one time. So if you're doing continuous projects, our average machine would have 8 tools on it. So if you're doing a lot of cabinet work or something, maybe there's 4 tools you use all the time. And then, so you can keep those always in tools 1 through 4, and then tools 5 through 8, you switch out with other ones as you need. I met a cabinet maker once, and I went into his workshop, and he didn't have a CNC, but what he had was 20 routers on the shelf. And I'm like, why? They're all the same brand. And I'm like, why do you have so many routers? And he said, because I have 20 bits I use all the time, and I hate doing tool changes. So he literally has that many routers on there just to avoid changing tools. So I wish I this was like 12 years ago. I wish I knew about this then, because he would probably benefit from a CNC with a tool changer. One of the nice things when you're programming a job is once your tools are on the machine, all you need to do when you're doing the cam, and I'll show you that in a minute, is simply call the tool number that you need. So you don't need to really remember anything. What we usually do is we keep kind of a notepad, or we keep a standard where certain tools are in certain locations. So when anybody is doing a job and they're programming something, they know, okay, tool 1 is always this bit, tool 3 is always this bit. So however you want to do it in your shop, that is one thing that makes things really nice, is simply change the tool number and you're good to go. Let's see, less manual tool changes. Obviously, it's more productivity. If you're doing a job that has 5 or 6 tool changes on it, you figure a couple minutes for each, plus re-zeroing the tool and then running the next file. It takes a lot of time. And if you're a production shop or you're doing work where you're looking to be as efficient as possible, then a tool changer is definitely the way to go. It allows you to run long projects without intervention. That kind of goes without saying, but I had a job I ran not too long ago that had 18 tool changes. There was 5 different tools, but the way the job had to be run, it had to constantly go back and forth between different tools. It was really complicated how we were doing this, but it was in a HDPE plastic, and we needed to put channels in it, and we had to use this gradually start with an 1/8 inch, go to a 1/4, and then go up to 5/16 end mill to make sure that the plastic didn't relax so much that it would start to curl. So there was a lot of tool changes, and this was awesome for that because I can't even imagine trying to do all of that with wrenches. The tool changer, I use one of our machines here in the shop. I hardly ever use it as an automatic tool changer, but what we do is we have a rack on the wall that I keep, say, 12 tool holders, and I keep them loaded up with tools we use all the time. So if I have a job that is only going to need one tool, there's really no reason for me to set up the whole tool changer for it. So what I'll do is I'll just grab that tool holder from the rack and just press the button on the side of the machine. It opens the drawbar. I can just slide the tool holder up inside, let go of the button, and it draws it up in there. It takes literally 2 seconds to change out a tool. So we use that a lot, and I have a lot of my customers that have these spindles, and they all use it the same way. Sometimes you just got to run something really quick, and you need a 1/4 inch upcut bit, and you've got one in a tool holder. Just hit the button and pop it in and run. So there is a lot of advantages of a tool changer for sure, you know, depending on your application. Even if it's just for manually quickly changing tools, you'd be surprised how much time it saves and how cool it is versus messing around with wrenches on your machine. So one of the things that we have on our tool changer, I saw my son goes to an engineering high school, and they have a Haas milling machine in there. I think it was a VF30. It's a $60,000, $70,000 machine. They had a full tool changer on it. And I went in one day, he was showing me, you know, how it runs. And at this point, the tool changer for us was relatively new. And every time you put a tool in, we would touch off the tool and then read the DRO to find out what the Z height was of that tool. And then we would manually put the offsets into our control software. And my son was showing me that he loaded up a bunch of tools on the machine, hit a button, and the thing came over, grabbed each tool, touched it off automatically, put the tool back, and before you knew it, everything was automatically registered. So I saw that immediately, came back, and we said, okay, we've got to write some macros and automate this thing. And all of our tool changers now, even the smallest one, all use the same macro sequence with CNC, which is the control software we use. And what it does, it auto touches off every tool, just like I saw on the big Haas machine. So I have a video here I wanted to play real quick, and just to show you what that looks like. However, I am going to check my screen yet one more time because I hear some people are trying to come in. Yeah, there's another person. I'm sorry. That's weird, Ted. I have to let people in. That's I feel like a bad host.
Yeah, well, I think that there's an automatic button, and I've got to look at that. I think it's set for manual, and that's probably my fault on my end. But
no, that's fine.
Thanks for doing that.
I can hear the dinging, so I don't mind letting him in. Now that I know what that means, so let me play this video real quick, and you'll see. I'm not going to play the whole thing. I just want to show you the auto touch off part. I'm going to scan up to 144 here. That's why I made that note. So on our machine, so this is, before I play the video, this is CNC. So this is what we use here. It's very similar to Mach 3. And in fact, everything that we're doing on CNC, you could program a macro to do the same thing in Mach 3. It's just we happen to use this software. I like it. It works really well. So we've been using it for years. No reason to change. But what we did here is we programmed an M4 macro. So you see the buttons M1 through M8. If you press M4, what it's going to do is a screen's going to pop up, and it's going to ask you how many tools you have in the tool rack. So you'll tell it, I have 3, 4, 5, whatever's in the rack. And then what it's going to do is it's going to go, and now that it knows how many tools you want to touch off, it's going to automatically start with tool number 1, and it's going to go all the way through in succession and record the Z height offset for each one. Now, say you break a bit, or you have one tool, like tool number 3, for some reason you want to change out. Maybe the bit's getting dull and you want to put a new one in. So what you do is you would replace the bit, put the tool holder back in the rack, and you would hit M4, except this time it's going to ask you how many tools you want to replace. You're just going to put in number 1. And so when it sees that you say I only want to change one tool, then another window will pop up and it'll say, okay, which tool do you want to change? So you would say number 3, and it would go over, grab number 3, it would touch that tool off only, and it would record just the new offset for tool number 3. So you don't have to go through and redo the whole rack every time if you just want to change one tool. So you'll see real quick in this video, I'll stop it when it gets to the point where we can continue talking.
To run the M4 macro. Now we have 5 tools inserted into the tool rack right now. So we're going to enter 5. This is telling you that it's going to adjust the offsets, which is the height of each different tool. The macro will start with tool 1.
One thing we've since fixed on this is we no longer have the Z retract height so high. It only goes about 3 millimeters above the top of the tool holder to make the tool changes quicker. And the tool length sensor that we're using can be anywhere on the table. So wherever it is for the first tool, the machine will keep going to that exact same spot with every successive tool. So the tool...
As you can see, the macro is now touching off tool number 2 to adjust the proper Z height for the tool. The macro is going to go through each tool on the tool holder and adjust each Z height for each tool.
So again, you could put that sensor anywhere you want on the table.
The best part about the M3 macro is that it is all completely automated with no user interaction. We'll speed this up here until it gets to the end of tool 5.
So anyway, you get the point. Where basically what it's doing is it's going to go through and do each one. At the end of the video, he's simply just showing you that there's a save button at the end. But this is what I really wanted to show you on this, was how it fully automates the touch-off process on each one. Now, the only requirement here is that the tool length sensor be on the actual bed of the material. So you don't want to have it on the surface of the work material when you're doing this. You want to keep it, because the bed is the solid reference point on the machine. So that's the only real requirement on that. Okay, so at this point, I want to design a quick project, and I'll show you in Vectric how we set everything up for the tool changer. So I'm going to switch over to VCarve here. I'm using VCarve Pro. So I'm going to make just a simple sign. It's nothing crazy, but we're going to create a new file, and the work material that we're going to use here is going to be 12 by 12 inches, and it's 3/4 of an inch thick. And this is a real project that we cut. I have video of that after. So I'm setting my Z0 to the top of the material, and my XY datum is going to be in the center for this purpose. So I'm going to click OK. So what I want to do is I want to come up with a border for the sign, and I don't feel like drawing one from scratch. So if you go over to Clip Art, Vectric comes with some really cool 2D vectors here. So we're going to grab this panel 2, pop it on the screen. Now what I'm going to need to do at this point is I want to center it. So I'm going to go over here and I'm going to align it to the material in the center. And as you can see, the vector automatically is made the same size as the width of the material. However, when I cut this out, I want to put tabs in on 3 sides, and I can't put tabs in on the side when the material is the same width as the actual project. So what I'm going to do is I'm going to make sure that the vector is selected, and I'm going to go over here and just resize it. So we're at 12 inches now. Let's go down to 11 inches. I'm sorry, let's go at 10.5 because I'm using a 1/4 inch tool, so I want to make sure I have enough meat left on the outside. So I'm going to apply that, and it's going to shrink the vector down, and it's also going to keep it centered, which is good. So this is going to be the outside of my sign. Now the next thing I want to do is I'm just going to bring in our company logo. So I'm going to import a vector, and I've got our Stepcraft logo here. It's pretty big for this, so I'm going to do the same thing. When it comes in, it's already highlighted, so I'm going to go over to resize again. This time I'm going to turn around. X and Y are linked, so it doesn't matter which one I change. It's a square object, so I want to make the width of this 3 inches. So when I do that, it automatically makes the height 3 inches, so I'm going to apply that. And now my logo it looks a little bit better for this size panel that we're doing. I do want to move it down a little bit, so let's put it right about there. Now the other thing I want to do is I'm just going to write our company name underneath it. So I'm going to go up here to the text tool. Trade Gothic is the font that we use commonly in our marketing, so I'm just going to type in Stepcraft, and I'm going to set my text height to 0.85 and just close that. So now here's my text. So I'm going to move it down roughly where I want it, and then I'm going to come over and I'm just going to make sure it's centered. So I'm going to align it to the material along the x-axis. So this is pretty much it. Like I said, very simple project. The point of this tutorial here is to go over the cam for the tool changer. So I'm going to come over to my toolpath tab, and I'm going to pin it so it stays on the screen. So the very first thing I want to do on this sign is I want to run a roundover bit along the outside, on this outside vector. So I want to put a radius, 1/4 inch radius on this all the way around. So I have a center point roundover tool that I'm using. So it's got just a point in there, and all I have to do is tell it how deep to go, and I just want to set it to cut on the line. So I'm going to use a profile toolpath for that. So it already came up here as my bit, but I have several in my tool library here. I have a few different diameter roundover tools that I've used. So we're going to keep this one here, which is that 1/2 inch diameter. Now, one of the things I need to do is you can do it when you edit it or when you select the tool, but I'm just going to hit edit because it was already pre-selected. And you got it right here. You want to assign the tool number. So in this case, it's going to be the first operation. So I like to logically place things on the machine in the way that I'm going to use them. So tool number 1 in this case will be my roundover bit. So I can click OK. I know that I want my cut depth to be 0.2 inches. Hold on 1 second. I thought I heard somebody else was coming in. Sorry, nope. Okay, and I want my cut depth to be 0.2 inches on this. It's a 1/2 inch bit. It's got a 1/4 inch radius on it, but I want to set a small reveal on it. You'll see in the finished. So in other words, I don't want it to be smooth on the roundover. I want it to have a slight step down off of the surface and then do the roundover. So I'm only going to go down 0.2 inches in this. Because I have the tool set for 0.12 inches per pass, it's automatically going to do this in 2 passes. So the only thing I need to do here is select my vectors. I want to go on the line. So I want to select this outside vector here, and I'm going to machine on the line. With this particular tool, I find it runs better in conventional, so I'm going to leave conventional selected here. And basically that's it. So all I need to do now is give it a name. Now when I'm doing tool changer jobs, what I just am kind of picky about how I do things. So I always name my tool, my operations with the tool number first. So I've got tool 1 and then a dash, and then I'll say 0.5 inch roundover. And that way I know when I'm looking at this as I'm compiling the file at the end, I know right away that this operation is for tool 1 and this is the bit I should be using. So I'm going to click calculate. Now when I simulate this tool path, it's not going to show up as a roundover because I never programmed in a vector profile for this bit. I just got lazy. So that's why it shows up this way. But trust me, it will do a roundover on the center point. So the next thing I want to do is I want to pocket the logo. So what I'm going to do here is select both vectors on the logo. Actually, let me check something because this might be a good trick. This particular logo, if I remember correctly, yeah, okay, it does. So I don't know if you guys have ever seen this before. Sometimes when you import DXF files, they have like an obscene amount of node points on it. And this file was actually done in Illustrator, and it was outputted as a DXF so that we could bring it in to Vectric. So this is kind of a side note, but as you can see, the shape of this doesn't need to be this complicated. And when you're running this on the machine, every single node point is saved as a separate line of G code. So it's really a strain on your computer, and because each one is treated as an individual vector, you'll notice when this is running that the gantry is going to jerk quite a bit, especially as you go through the radius. So instead of a nice smooth curve, it's going to make a really lot of jerking actions as it goes through here. So a quick way to fix this is to just simply come over here to the curve fit button, which says fit vectors, curves to selected vectors. And you're going to want to select Bezier curves, the center one. Because this has outside corners that are sharp, I'm going to keep sharp corners, and I'm going to set my tolerance to 5 thousandths. And then I also want to replace the selected vectors. So I want to replace what's here with something cleaner. So I'm going to go ahead and I'm going to click preview. Now, as soon as I do that, you notice how many node points there are now. There's like 10, maybe, if that. And everything is much smoother. Now, this vector had some imperfections in it already. It's probably in the way it was outputted. But so you really don't, like, from here to here, you don't need a node point here at this one spot. You'll really only need 2. But I'm going to leave it alone because this really isn't about node point editing. But I just wanted to show you this is going to run on a lot less lines of G code. It's going to run a lot faster on your machine, and the file size will be a lot smaller too. So we're going to come to this side now, and you can see it has another ton of node points. And I'm going to leave everything the same. Just click preview. And you see that simplifies things as well here. So there's a lot less node points. I'm just going to click OK. And so now all I want to do, because I want to pocket this out, I'm just going to select both of these vectors, and I'm going to go back to the pocket toolpath. So because I know I can't get a tight square corner with a round end mill, it's just impossible. I want to get it as close as I can. So I'm going to use an 1/8 inch end mill here. So when I go to select my end mill, I can select it from the library. I'm sorry that these were already preloaded from before because I set up this file earlier so we could shoot a video. But I'm going to go in and I'm going to edit this file. And you can see right here, I've assigned this, since this is the second operation, I've assigned this tool as tool number 2. So in the tool holder, this will be the second tool that we have in there. I'm going to pocket down 1/8 of an inch from the surface. And I'm going to do an offset clearance instead of rastering back and forth. I want my end mill to kind of follow. I want it to follow the outline of the vector. Okay, so that's really all we need to do here. I'm going to name this one. So I'm going to name it Tool 2, 1/8 inch end mill. I'm not concerned about what type of end mill or anything like that for the purpose of this, just an 1/8 inch end mill. I'm going to click calculate. So I can preview that toolpath, and you can see now I've got a nice pocket there. So far everything is looking the way I want. So I'm going to go back and do the third operation, which is going to be the letters. So what I want to do here is V-carve these letters. So when you set text on your screen, it's automatically grouped together. I have no reason to ungroup it. I'm just going to handle it just like the Vectric created it. So with that selected, I am going to come over here to the V-carve toolpath. And I'm not going to set a flat depth on this. I'm going to let the flat depth, or the maximum Z depth, be determined by Vectric based on the width of the bit I'm using. So in this particular case, I'm using a 90-degree half-inch V-bit. Essentially, this bit I'm using was one I bought from Home Depot. It's just a 1/4-inch shank, half-inch V-bit, nothing fancy. It is the third operation, so I'm going to put this in tool number 3. So again, I can change this to anything I want, but this is going to remain in tool number 3 for this operation. So I'm going to click OK and calculate. Oh, you know what? I didn't name it. My bad. So we're going to call this tool 3, 0.5 inch 90-degree V. and calculate that. So I'll preview that, and I could see, okay, the letters look good, everything, it's deep enough, it's not too deep. That's exactly what I'm looking for here. So the last operation is going to be to cut this out. So what I want to do here is just select the outside profile, and I'm going to go back and do a profile toolpath. This time I'm going to set my depth to 3/4 of an inch. Normally I would go, well, actually I'm going to do that. I'll go 5/1000 over. I'm using a spoil board on this, so I want to ensure that if there's any deviations in the material thickness that I'm at least getting through the bottom. So I'm going to go 5/1000 into my spoil board. I'm going to change my tool here. I'm going to use a 1/4 inch end mill to cut this out, just a basic one. And in this case, this is the 4th operation, so I'm going to call this tool number 4. And I'm going to click OK. So this is telling me that it's going to take 3 passes because this particular tool is set to do 1/4 inch per pass. These settings are fine. The Q can actually do, with a 1/4 inch end mill, I can go through a 3/4 inch piece of material. I could do it in 1 pass, slower, but I can do it at an aggressive speed in 2 passes. But I'm just going to leave this set to the default for 3 for this purpose here. I want to change my machine vectors. I don't want to cut on the line now because this represents my finished size. So I want to make sure I'm cutting outside the line. So I'm going to set that. I'm going to keep conventional. That's fine. I do need to add tabs to the toolpath here. So I want my tabs to be a 1/2 inch long and an 1/8 inch thick. So if I click Edit Tabs, I don't want to put a tab up here or here or here. And the reason is because I hate sanding off tabs, especially on a rounded surface. And, if you sneeze, you push it into the wood, now you have a flat spot there if you push it into your sander. Cutting tabs off here and here and cleaning them, I don't know, it's just a pain. So I just do 3, but I'll put 1 here and 1 over here so that they're at the high side of the part, and then I put 1 in the center. So between these 3 tabs, this part's not going anywhere. I don't have a reason to put anything up top. So this should be a lot quicker for me to clean these tabs off after. So I'm going to close that, and that's basically all I need to do here. I just need to give it a name, so we'll call this tool 4, 0.25 inch end mill, and calculate. It's warning me that I'm going to go through into my spoil board because my thickness is set to 3/4 of an inch. Click OK, and now I'll just preview the selected tool path. And now you see here, this is what I was talking about. Because I didn't create a vector to match the radius of that tool, it's actually profiling it as if it was a standard end mill. That's why it looks like it's got just a square drop here. That's something I'll have to fix after and set that up. But I've got my 3 tabs set there. So this part is all set to cut out. So now the only thing I got to do at this point is save the file. So it's actually really easy. If you go over your Save Toolpath, I have my post processor set for my machine. So I've got just the Stepcraft ones in here. Yours will have yours for your machine, or if you didn't set my post P in Vectric, you'll have all of them there that they ship with the machine. So what I'm going to want to use here is an ATC tool, but I want to show you a regular one first. So a non-ATC profile. If I want to go ahead and I want to output this file, I can click here and I'm going to select all 4 toolpaths. And I'm going to get an error because I'm saying to output all visible toolpaths into 1 file. However, because each toolpath is using different tools, Vectric's not going to let me save that because this post processor is not a tool changer post processor. It doesn't have any references in it for the M6 command, which is a tool change command for G-code. So you would have to make sure that you're using a post processor that supports a tool changer. And I can't speak for every machine. I know it's possible for every machine. It's just a matter of what that looks like. And if anybody wanted, you just email me. I can send you our post processor so you can look and see what the G-code headers were added to it. Or if you go into your copy of Vectric, if you should be able to find our post processors in there. You can just look at them yourself. So I'm going to change this to a ATC post processor, and now that error goes away. So now it's telling me that the tool paths to be saved are 1, 2, 3, 4. And I named it tool 1, but you'll see here what Vectric does is in brackets, it assigns the tool number. So it shows you right now, these are the end mills that you're using, and these are the tool numbers that you're going to have. So then all I have to do at this point is just save the file, and then I can go and bring it over to the CNC and run it. And everything is already in there now for the tool change commands. So that's pretty much it. I could have done this a little bit quicker, but I wanted to show more than 1 or 2 tool changes. So I'll go back to this presentation so this is the video that we made earlier today. So I've got the MDF. It's a piece of 3/4 inch MDF on the machine on I believe that's a 1/2 inch piece for a spoil board. We have it clamped down. Our tool rack on our 204 machine is actually on the front. We can put it on the back as well, but when it's on the front, I can have a larger tool stick out. And I use some tools that have to stick out 3.5 inches for like foam cutting. They're pretty long tools. So when I put the tool rack on the front of the machine, I can, because we use a T-slot plate here for our Z-axis, I can move my spindle up higher, which means I can have more stick out between the collet and the table. So that's why we have our tool rack on the front, in case you were wondering. So I'm going to quickly play this video. There's nobody talking over it, so I can talk. You'll hear the machine. I'll lower that volume a little bit. So this is the roundover bit first. Now, mind you, he's already touched off all the tools, so that was already done ahead of time. So we're going to do 2 passes with this end mill, mainly because this end mill's old and it's kind of not as sharp as it used to be. So I could have done it in 1, but we just get a better result when we're using it with 2. It was I bought it off Amazon. It was a really inexpensive center point end mill or center point roundover. So now we're grabbing tool number 2, which is our 1/8 inch end mill, and we're going to go over and pocket out the logo. Thankfully, when Dylan shot this video, he did speed everything up. Otherwise, we'd be sitting here for 20 minutes watching this run. We didn't run this super fast either. We don't have a dust collector on this machine. We took it off so that you can actually see the interaction with the tool and the material. So now we'll do the V carving with the letters. You'll notice right here in the video, see this arm, you just saw it maybe come down. So one of the things that we designed here actually in the States, we have an automatic dust boot on this machine. We just took the dust boot itself off for the video. But what'll happen is there's a pneumatic cylinder there. So when the spindle turns off, when it's ready to do a tool change, it retracts upward so that the dust boot doesn't crash into the tool holders. And when the spindle starts back up again, the air cylinder releases, and you can see here it's in the down position. So now the dust boot stays in constant contact with the material. The other nice thing is it's not pneumatically pushed down. It uses gravity to push it down. So what that means is that the dust boot always stays in contact with the surface despite the height of the Z-axis. So if you're doing a carving job that has a lot of Z-axis movements, the dust boot always makes contact. So it keeps the work area much cleaner. But this is the finished project. Very simple out of MDF. But you can see this is the reveal I was talking about. So I pushed this down, so instead of the roundover being even with the top, I wanted to have a straight lip around the edge. I just kind of like that effect. So that's basically what we're doing with the tool changer. It's really not that hard to set up the program. So on the next slide, I know maybe some of you guys are wondering, can this one of our ATCs work on your CNC? The short answer is probably. The following things are required in order to make it work. I have a couple customers that have integrated our ATCs on other machines, but I can't speak for every controller, every machine. every mechanical assembly on those machines in the market. So if you wanted to integrate it, we would certainly do all we could to help you, but there's some things you're going to have to find out on your own. One of them is you need a way of mounting the spindle to your machine. Again, the HF500 and the MM1000, the two smaller ones, need a 43 millimeter collar. So you would have to maybe make a custom bracket with a 43 millimeter circle to hold it and to support it. That's what I just said. And then the 2200, which is the bigger one, if you have a larger CNC, has a backplate mount. So there's 4 M8 bolts that anchor it to the Z-axis, and I believe they're 100 millimeters apart from the left and right, and 100 millimeters apart up and down. But I can certainly get you those exact dimensions so you can mount it. But it is a direct bolt-on through the front into a backplate. In our machine, it works out nice because we have T-tracks, so I just use M8 T-bolts or T-nuts in there, and that's how we anchor it. Your CNC controller has to have an output that can be assigned to the M6 macro. And that's the macro that you use to open and close the drawbar. The air solenoids that we use that are most common are 24 volt DC. So you don't necessarily have to have an output that delivers 24 volts. If your output delivered 5 volts and your solenoid needed 24, then you could run the 5 volts through a relay and use a 24 volt power supply to power the solenoid. But you do need to, when the controller software sees an M6 command in the G code, it needs to be able to trigger an output on your CNC that will open the air solenoid. And that's what opens the drawbar. And then when the M6 command is given again, then it releases that output and it closes the drawbar. So that's one thing you'll have to know on your machine. Your CNC software needs to have custom macro capability because a macro is required to tell the CNC what to do and where to go for each tool location. So we wrote a macro for our tool changer that basically what it does is when you set up the machine, you manually run the spindle with a tool holder into the tool fork. And once you get it in the tool fork in the location where you want it, you record the values of the DRO into the macro, because every machine is going to be set up slightly different. If the tool rack on your machine is off 1/8 of an inch from another one, you have to tell the macro what the exact location is, X, Y, and Z for each tool holder. You only have to do it once. As long as you don't remove the rack from your machine, you should never have to adjust it again. So it's part of the initial setup, and it takes a few minutes. It's not hard, but you will have to have a macro that then says, okay, because when you're given a G-code command that says M6T2, then basically that's saying, okay, we have a tool change to grab tool number 2. So the macro has to say, okay, when I see that command, I want to raise the Z-axis to a certain height so it clears all my clamps or anything that's on the table. We raise it all the way up. Then we move it over to the tool rack to that XY location where that tool 2 is. And then we want to lower it down, lower the Z down to the exact height for that tool to fit in the tool fork. So that's a macro that you have to have. If you're using UCCNC, no big deal. We have those. We can share them with you. If you're using Mach 3 or something else, I know it's possible, especially with Mach 3. You can do pretty much anything with that software. I'm sure there's guys online that have the M6 macro for that you can use and adapt to your machine. You don't need a custom macro for the tool touch off that I showed you before in that video, but your software should have the ability to record the tool offsets manually. So if most software does, I know again Mach 3 does and UCCNC does, what you'll have to do is just manually lower each tool to a tool length sensor and then record your DRO values into your tool offset. You'll have to actually calculate the Z height difference between tool number 1 and every other successive tool. So if tool number 1 stuck out 2 inches and tool number 2 stuck out 2 1/4, then your tool offset is 1/4 of an inch. So you'd have to put in, it would be negative as well. So you'd have to put in negative 0.25 inches in there. So that's how you would do it. If you could get a macro that automates it, like we have, like I showed you in the video, that makes your life so much easier. You need 110 psi of air. I'd said that before. And if you wish to use the RPM control from the G code for either the HF500 or the larger 2200 ATC, you need to have a 0 to 10 volt PWM output from your controller. So we're using a PWM output that is variable from 0 to 10 volts, and that's what is telling the controller for the HF500 or the VFD how fast you're going to want the RPMs to go. Some machines will have 0 to 5 volts, and I know like on a VFD you can program it to do either 0 to 10 or 0 to 5, so that's fine. But you need to have that PWM signal that's assigned to your RPM in your G code. So those are the things you have to find out before you were able to integrate it. But most CNC machines on the market should be able to handle this without a problem. Some of the smaller ones, some of the desktop machines like a Shapeoko or something, they use their own kind of software. I'm not sure what their capabilities are as far as macro programming or the ability to use a tool changer. You'd have to ask them if it's possible. You'll also need a output from your controller to tell the spindle to turn on and off. You'll need that for any of them. You can't use a tool changer without having an output to turn the spindle off. You can't have the spindle spinning when you go to put the tool back into the tool holder. So that's pretty common, but that's one of the main things that's mandatory. So the ability to have an M6 macro to program the location of each tool holder and the output for turning the spindle on off are the two major requirements to be able to integrate with your CNC. So I guess that's pretty much it. I know it's a lot. What are we on here? An hour, I guess. Ted, I guess we're okay. I don't know if anybody has any questions that I can answer.
Yeah, we're fine. I'm sure that there's going to be some questions here in the group, so go ahead, guys. If you got a question, open up your mic, ask your question, and then close your mic, and we'll try to answer them for you.
Is the move when you go to change tools a rapid move or a slow move?
You can set that in the macro to the speed that you want. I have it set to, usually it's about 75% of max speed on our big machine. On the smaller machines, I do it at max speed. So our D-Series machines have a 50 millimeter per second max speed, which is about 110 inches a minute. And the Q-Series machine is 230 something millimeters a second. So it's 470-ish inches per minute. So I don't like running that fast when I'm traversing my project. Again, that's why we program the macro to bring the Z-axis all the way up, because I want to make sure I don't, because the spindle doesn't know if there's a clamp or a fixture in the way. So, I always run safely by bringing it all the way up so I don't crash into anything.
For a machine that is not a Stepcraft, what's the hardware cost for each of the three sizes?
Oh, that's a good question. Let me go back to pictures where those were. So the HF500, you're looking at roughly $12.99 for the spindle and the tool changer and the control box that goes with it. So it's right around $12.99 for this setup. However, the MM1000 is also around $12.99. They're very similar in price. The main difference between the two is because this is computer controlled, there's a controller box that comes with it. And so there's a little bit more cost involved because the RPMs are variable. Also, that's one thing I didn't mention. This spindle is a DC brushless motor that it uses inside, where this spindle is a AC brushed motor. So that's another difference. So the spindle here is actually $3.99, but the tool changer, because it's larger, is $8.99. So you've got the tool changer is more expensive in this case, On this particular one, the tool changer and the spindle are about the same price, so they both equal out about the same. Now, this one's a different story. This one is $39.99, so it's almost $4,000. It's definitely not a router, and it's not as inexpensive as the other ones, but when you see the spindle, it's a 23.5 pound spindle. It's meant for high production work. We sell probably 4 out of every 5 Q machines we've sold, and since we released the spindle, have gone out with this spindle. Because whether you want to use it for automation or whether you want to use it just for quick tool changes, the power and the fact that it's maintenance free, and you don't need water cooling, and it's really quiet. I mean, there's a lot of benefits to it.
That's in the ballpark of what I would have expected.
Okay, well, that's good. Anybody else have any questions?
Well, it was a great presentation. I certainly learned a lot. I think others were very enlightened to be able to get the information that you had presented. There was a lot of information here tonight that I think a lot of the viewers will find very interesting. It's nice to know that you can actually have a lower cost, real good, high quality machine for an affordable price, and that I hadn't seen in the past. Mm-hmm.
Yeah, well, I appreciate you having me on and giving me a chance to talk about tool changers. I mean, in the world of like our video had said there, in this price point, especially for the D-Series machines in that, say $2,500 to $4,000 price range, there's really nobody else out there that offers automated tool changers for those machines. So that's something we've been proud of since for a long time now, many years that we've had that. Getting into the Q machine, when you get into a production machine like that, you have to have, if you're really doing it for business, it's a worthwhile investment for sure. So I appreciate the opportunity to let everybody know about these products, and hopefully I answered everybody's question and informed you a little bit about what it's like to use a tool changer. It's really not that hard. I think once you get it integrated into your machine, the rest is pretty easy.
Yeah, I think it's just initial learning curve, getting it set up, and just like setting up your own CNC machine, there's a little bit of a learning curve initially, but then once you get it all up and operating, life sure becomes a lot easier.
Yeah, it does.
The other thing that I wanted to mention was, I know we don't have time to go over it tonight, but I was very intrigued to see all the other attachments that you have for your machine. Maybe someday in the future we can get you on. You can explain to us about your other accessories that you have for your machines. I found it interesting that I hadn't seen it before. People putting hot knives for cutting foam and things like that on their CNC machine. I never really gave that much of a thought, for a CNC machine. I've seen, people use drag knives and things like this on their CNC machine, but to put a wood burning tool and those other things, I can see where there'd be a use, but I don't know of anybody that's actually out there promoting them.
Yeah, there really isn't. Not in the States. It's not very common. You'll see companies that might have a laser on there, 1 or 2 that might have a 3D printer, but we have over 12 attachments total, including 4th axis for all of our machines as well. One thing we could do in the future, if you want, is I have a process that I've developed using this drag knife on our machine for masking off when you have V-carved letters, or if you're doing a sign and you've got a pocketed area and you want to paint the pocketed area without getting overspray on everything. I have a way of using the drag knife to do that, and it literally gives you perfect results every time. And I read a lot of guys are using Aura mask and milling through it and all kinds of stuff like that. But the drag knife is something that makes that process like super simple. So, that we could maybe look at our attachments in the future in application form instead of it, talking about the actual attachments. I would do explanations of how we use them, like some unique ways of using some of these attachments to get jobs done.
That'd be wonderful, because I think there'd be a lot of interest in that. I know there's an awful lot of interest in guys putting lasers on their machines. Is your laser adaptable to other people's machines?
Yep, absolutely. You can use it. It's just again, you're using the same PWM signal that you would use for the RPM control to control the laser power, and then you'd have to have a post processor that you use in Vectric that will basically just reassign your spindle RPM that will turn that into power. So we have the Vectric. If you go to there is a laser post processor that they should have defaulted in there for that. But yeah, no, it works. It should work with any machine. You just have to wire in the laser control to that signal.
Okay, well, thank you very much. I'm going to I'm going to go ahead and take over, reclaim the presentation role. So I got my screen back here, and then we'll have this up on the screen here for us. Let me get out of that. Let's see if I can do this here. Well, that's okay. Okay, I've got it back. Everybody can hear me okay?
Yep.
Okay. Well, we'll go ahead and end this tonight. I just want to remind people that if they missed portions of this, you can go to YouTube and you can do a search for Michigan CNC webinars and tips. And I will try to have this posted by tomorrow. So if you want to use it for a refresher, or if you only caught part of the presentation, you can go back and see it. As with all the other presentations, we try to do these webinars the first Tuesday of every month at 7 p.m. And once again, I would like to thank Erick Royer for taking the time out of his evening. I know he had to come especially into the shop tonight to do this presentation. So thank you so much. It was very informative, and we really appreciate the time you spent.
All right. Thank you very much.
Thank you very much, sir.
Okay. Take care, everybody.
All right.